Gelukt?
Heb je ook moeite?
Nee.
Oké. Gelukkig.
Jesse. Je bent al mute.
Jammer.
Hi. So, everyone is joining already. I can't see everyone. Maybe I can. So let's just wait until everyone has chose their session, which they want to join. Maybe if you joined, please let us know in the session chat beside the screen.
Yeah, but you can also see at the top side of the screen that there are now 27 people in this session. 29.
Oh, yeah. Great. Let's just wait a while before we start. All right. I think with 40 people in, we can start off. First of all, thank you for joining, everyone, and choosing the best session because, well, quantum internet, well, for me, looks to be the most interesting session. And I can't wait to hear more about it. I'm Jelmer Knuivers. I'm product manager. And for now, I will be the host or the person who will interact for you. So basically, that will say if you have any questions during this session, you can just put it in the chat, and I'll make sure the question will get asked. But before we start, I want to thank Jesse to join. Jesse is co-founder and director of Quantum Delta in Netherlands. This new institute was recently established by the Dutch quantum ecosystem of companies, knowledge institutes, and governmental institutions to accelerate the leading role of the Netherlands in quantum technology. And Jesse is also representing the Netherlands in this field of technology. And besides these activities in quantum domain, he is also a senior business consultant at TNO ICT with a specialism in the field of digital infrastructure, internet, cloud, and media, and coordinates also the Dutch part of the Gaia-X activities. So he'll now give a presentation about 30 minutes into the future of our digital infrastructure. And we'll share some actual examples of what currently happening in the field of quantum technology and actual plans on quantum networks. So it's really exciting. I'm really looking forward to his presentation. So for those who just joined, if you have any questions, please enter them in the chat. I'll make sure they'll get asked to Jesse. So for now, Jesse, I want to give you the word for your presentation, and thank you for being here.
Thank you very much, Jelmer, for the introduction. Share the slides. Where is the button? Doesn't want to share the slides. He doesn't want to share the slides to the Hopin platform. check. I'm going to log in again because this is not going to work. Sorry, guys, need to log in again. I'm back again, but I can't hear you now. Yeah, I can hear you now.
Okay.
I can share.
If you're unable to share your presentation, I can share the PDF you sent.
1 sec. Yeah, now it's working. No,
Great.
So sorry for the delay. Thanks again, Jelmer, for the introduction, and I hope everybody can hear me well. If not, raise your hand or shout. I'm gonna give you an overview on what's happening on the quantum field a bit. I'm not the specialist like Pep introduced about boson parts and everything around it, but I've made a translation for what's happening in the technology labs, especially within the Netherlands, to what can be done in the field in a couple of years from now. And that's also the fundament of the entity Quantum Delta, the Netherlands. Moving on to the next slide. What is quantum? And if you go into the shop or if you're going online, you see a lot of quantum where you will be confronted with. Soap for your washing machine with quantum balls in it, Firefox quantum for enterprise, and even in your paint there's quantum on it, but it's all marketing. Unfortunately, nothing in this picture or in this equipment or in this technology is quantum. This is only marketing at the moment, and there is no qubit or quantum computer behind it. But everybody is confronted with it already. But quantum is a topic that is already quite in the news, and if there is a development there, it's often big news, it's front page news, because everybody thinks and is focusing on the breakthroughs around quantum technology, and many institutes, big tech companies are currently working on the development of quantum computers, quantum networks, and everything around it. And last couple of months, years, we had different breakthroughs which were on the front page. A little bit of background of quantum. Quantum is not new. It was already touched by Bohr and Einstein in the 90s, where they were elaborating what is happening with quantum technology, what is happening with the elementals of the background of quantum technology and the atoms, and they found already some theories about quantum superposition and entanglement. And so quantum is not that new, it's already there for years, but is now becoming more concrete than ever. We are all aware of a bit and a transistor, where a transistor is a 0 or a 1. But what they found out with quantum, and they call it qubits, a qubit could state a 0 and a 1, and a combination of a 0 and a 1. And that makes it possible to have more computer capacity than with traditional transistors. And that's the important fundament for developments around quantum technology. So with 3 bits, you have a couple of numbers between 0 and 7, but with 3 qubits, you have all the numbers at the same time, and that gives the possibility to build new calculations, new algorithms, and everything around it. So the expectation is, if you look into the law of Moore, that quantum is the next step in the developments of chips, transistors, and the race for faster calculations and everything around it. And especially also in the Netherlands with the developments of the chip machines of ASML, we have a quite strong role in that development. And quantum technology is also very important for instance, Dutch market and the relations that we have worldwide in the chain of development of chips and new technology here. So that qubit has a 0 and a 1 and a combination of a 0 of a 1, but also they found out the entanglement, and there they found out that with an interaction between two quantum qubits, both qubits could be having the same position. So a combination of a 1 and a 0 on the Alice side and a 1 and a 0 on the Bob side, and they could sync with that entanglement, which gives new opportunities if it comes to quantum networks and quantum internet. For instance, you don't have to send all the data from Alice to Bob, but with an entanglement solution, you could synchronize already the qubits on both locations without transporting the full data set. Why quantum technology? Now, if you translate that to the possibilities, it will give possibilities for quantum computers, quantum networks, and quantum sensing. So it helps to develop new materials and complex things in the chemical industry. It could help us more in the development of medicines and vaccines, interesting these days, and of course to work on complex problems like climate change and weather conditions. It could help us in securing network communication. It helps us to build up the future of the current digital infrastructure. And there are a lot of possibilities if it comes to quantum sensing, with sensors that can be built within medical machines, could help to find out different elements in the ground and see how that is affecting our life or development of the Earth. And it could help us also in the development of new space instruments and everything around it. So quantum technology, in our opinion, will affect many sectors. And also, if you have discussions with the different sectors, from the petrochemical to the medicine industry, they all see possibilities and investing at the moment in quantum technology and see how can they take benefits from it at the moment. And the promise of quantum technology is unlimited calculation power. This is the computer in Japan from Fujitsu Siemens, which is currently the most powerful computer that we have on Earth. But we expect in 5 to 10 years from now that we can build some elements of these computers based on quantum technology, probably in a sort of hybrid model, but it will help already to speed up calculation power there. What we see at the moment is that if it comes to the applications that you have with quantum technology, that for quantum computing, it will take time before the real full quantum computer is there. But in the developments to that final quantum computer, we can do already elements with it and do already calculations with it and support what's happening there. With quantum sensing, it's more close by. The hardware is already available these days, and currently the industry is looking, how can we build applications, how can we translate it to industries, and how can we make it already touchable and integrated in different solutions. And there we're focusing also in with the industry, how can we support it and move that further. For quantum computers, for quantum communications, it's a little bit closer, it's much closer by than a quantum computer is. Today, it's already possible to build up quantum point-to-point networks between an Alice and a Bob. There's already the first hardware available to encrypt with quantum technology and generating quantum keys existing and classical data networks. And a couple of years from now, we see already the first deployments of these networks and already adoption by different parts of the industry. And then we're working already on simulation, which helps us to translate the quantum technologies from computing and quantum networking into potential applications and solutions, so that we already prepare for what's coming if the hardware and software is ready in the quantum computing and the quantum communication area, that we have already applications available that we can implement on these quantum computers and quantum networks. Jelmer, are there already questions that we need to ask?
We have. So again, if you have any questions, you can enter it in the chat. And we have a question of Michael V, who was wondering about the entanglement. He asks, you don't have to transfer the entire data set to have it on both sides. Did I understand that correctly?
Yeah, that's correct. That's what we try to translate with the entanglement currently within the quantum network chain at the moment.
And so he also asked, what's a quantum key?
A quantum key is an algorithm that is implemented within a couple of qubits, like an encryption key that you use for encrypting the data today. With quantum key distribution, it's possible to send the key, so an algorithm within the qubits, the zeros and ones, in the qubits that can be transported from an LS to a Bob location and can be integrated again in the data set. So on one side, a key is generated that is used to encrypt the data on a classical network. The key will be distributed by the quantum key distribution network to the other side. The data that is encrypted with the quantum key is distributed by the classical network, and on the endpoint, it will be combined again and the data is available.
Okay, thank you.
So
there are no further questions. So
okay. So why now? Currently, there's already a lot of development in the network and internet area. So in Asia, but also in Europe and Switzerland, the first quantum key distribution boxes are deployed and ready for production. So there's already a lot of developments going on also in that field. In China and in the United States, there's a lot of investments done in building research and development networks by fiber and by satellite to do experience with quantum networks by space and terrestrial. And in Europe, there's a big push by the European Commission to deploy national and international networks that can be used to protect data on the right way. And there is a sort of promise and idea that quantum technology can help with unhackable solutions. And we need to find out if that's really true, but there is a really belief that we need to develop this in Europe and take our responsibility in a sort of sovereign development of networks and technology in that field. So there's a big push and there's a lot of developments in different continents in the world. And the Netherlands started also with these developments and started with the first quantum network link in 2015. It was built on the campus of the University of Delft, where they had the first entanglement and the first quantum key distribution network locally on the campus. And that was a breakthrough globally. And even it was front page news of the New York Times that we reached that milestone. If you translate what quantum internet could bring, so it starts, as I explained just a minute ago, with point-to-point transmission of qubits, with quantum key distribution technology, where you have a point-to-point solution to encrypt data that can be transported on a classical network, where it moves up to a multi-point to multi-point qubit transmission, where you can use a centralized node to identify and to control all the data that is transported, the authentication and the encryption. Translate that to next development where you have the quantum entanglement, where you can set up connections to transport data, but not the full data set needs to be transported there. And then when quantum memories are ready and could be implemented in the hardware, then you can make a real translation to the networks that we have today but then on the quantum field to build a cluster of quantum computers or long-distance connections between different quantum computers. So that will bring the upcoming period. If you translate it to the first quantum network applications, that could be, for instance, in the financial world, to distribute master keys to protect the financial system. That could be to encrypt data between data centers. That could be used for encrypting and secure data that needs to be transported to a base station of a mobile network. And that could be used in several governmental solutions, critical infrastructure, and other chains where at the moment data is important, that it is not able to be hacked or need to be protected. Any questions? No? Okay. Then at the moment in the Netherlands,
we actually got one now from Sean O'Neill. Any new developments to avoid decoherence?
Yeah, I need to translate that, Sean. Could you elaborate?
Could you further elaborate what you mean with decoherence? In the meanwhile, just go further with your story. Then I'll interrupt when Sean.
So in the Netherlands, we have a strong ecosystem of research institutes that at the moment investing heavily in quantum technology. That's happening in Delft with QTech, which is an organization that is a combination of the Joint Institutes, Research Institute TNO and the University of TU Delft. In Amsterdam, we are currently focusing on the development of quantum software, and in Eindhoven, we are focusing on the use cases and deployment of quantum networks with boxes that are out in the field and translate that to use cases in mobility and smart housing. Come back later on it. And in Twente, we are focusing on the photonics side at the moment. How can we implement the photonics developments into the quantum technology that can help us to build up new networks, but also the connections that are necessary within a quantum network. In the Netherlands, we built a large agenda for it in 2019 that we can focus. How can we focus with this technology on new products and services? How can we build a revolution with this technology? How can we play a further forefront role in these developments that we are leading at the moment, also in the Netherlands, but also on an international level? And how can we heavily investigate in research and innovation to drive the developments that we have in the Netherlands, and also build up a sort of center of excellence around quantum technology driven from Netherlands and within the EU.
I have two questions. Well, Sean explained his question, and they are quite technical. So I hope I can pronounce everything correctly. So decoherence, where Sean talked about, is the consequence of interaction of physical systems with the environment, and in quantum it destroys superposition.
I'm not that deep technical, so I can't answer this answer. Sorry, Neil. Okay.
So and maybe then you can answer Michael V, because this one was semi-related, according to himself. Is what is a qubit physically? An atom in superposition? If so, does that mean that the quantum network will move towards transmitting atoms instead of electrons?
Yeah, that it will indeed transport atoms instead of electrons. Yeah. But again, I am not that deep in that technology, so I can't fully answer the questions in that detail.
Okay. Thank you. And also thank you for the questions.
Yeah. So what we have done in the Netherlands is that we start building up a program to boost quantum computing developments, quantum network developments, and quantum sensing developments. And if we focus on the national quantum network stuff, we want to deploy quantum networks in a couple of years from now, want to connect different locations within the Netherlands, link potential users, use that as a test bed also to connect quantum technology, quantum networks to cloud setups, mobile networks, and security applications, and build really a sort of ecosystem to boost the industry around quantum technology for hardware and software and future applications. And of course, in really close cooperation with all the international developments that are going on at the moment, because close cooperation with developments in the US, in different countries in Europe, but also Asia is important, because standardization is also crucial, as we all aware, in the network industry. So in NANS, we built up different R&D networks. Go a bit later on it. We will go for a national network, which is a stable operational network, where you can deploy applications on and build up application on, and then we can translate that further to developments within the industry, financial industry, governmental industry, and the service provider in the internet infrastructure and in the telecom infrastructure. The goal is really to build that national network. We have already some test networks, R&D networks in the metro area of Delft and Helmond. One of the networks is also touching the actual office of NLIX. Different qubits already passing the office of NLIX at the Beatrixlaan in The Hague these days, because it's part of the test route that we have at the moment between Delft and The Hague. And on short notice, we will extend it to Rotterdam. And in Eindhoven, we're building different test beds to the mobility area in a city close by Eindhoven, and a smart housing area in Waalre, where we can protect private data that's coming from different houses. So in Eindhoven, again, the test bed that we are building there, and see how we can build use cases on it the upcoming years. Doing integrations between quantum network and classical networks there, because as I explained, you can distribute a key from one to the other side with the quantum network, but you need to encrypt the data on the classical networks. And that's, for instance, necessary if you distribute private data from people like just you and me, that's created in your house and needs to be transported, for instance, to an energy company, or you use it for other purposes. Currently in Den Haag, Delft, we are deploying a central node at the moment for quantum key distribution to work on encryption, authentication, and integrity that we can use, for instance, in the governmental area to protect data, privacy data that need to be transported between tax offices or between security agencies. And in Eindhoven, we are really building use cases around self-driving cars and 5G, where we would like to protect the data that needs to be transported to a base station of a mobile network, and from the base station, of course, in the end to the car, so that we are really sure that the car and the chain to the car won't be able to be hacked and be interfered if there's a self-driving car really up and running. And as said, in the area of Delft, Den Haag, there is already an existing running network that is running at the moment from Delft to The Hague and back through the office of NLIX, as I've learned the last couple of days, because the guys of NLIX moved to another office recently. And we are going to extend this with the educational network in the SurfNet to an additional node to build up really that quantum network chain, where we not only looking to an Alice and Bob, but recently we had a breakthrough that we have built a Charlie. So we have a sort of repeater function there that we implement there, so that we can reach longer distance than we can reach today. Now, it's not done only in the academical world or the institutes at the moment. It's done with the government, with the banks, with other organizations that are involved, but also with the infrastructure providers, because that ecosystem is necessary to drive the developments around quantum network and quantum internet. And also, for instance, from the financial world and the government world, they're really interested in this technology, because that helps to secure their banking system, or it helps to exchange their privacy data between different entities on national level and on international level. I'm talking all the time about the quantum network layer, but the orchestration layer, the integration with the existing data infrastructure will be very crucial there. That's also where a lot of focusing is at the moment to drive this further, to take the developments there, because you work in the first networks with a sort of hybrid model, and also we have an existing infrastructure that we can upgrade with the quantum technology that's upcoming the upcoming period. And on international level, if it comes to quantum networks, there's also a lot of things developing at the moment. Maybe you have read a couple of developments in China as far they are publishing there, but they have the goal to build a large terrestrial network by fiber. They do a lot of experience at the moment with quantum key distribution by satellite, but also in the US and in different parts in Europe, like in Bavaria of Germany, and in the eastern part of Europe, southeast of Europe, there are deployments of networks the upcoming period where they start off testing and build up applications on it. Also in the Netherlands, it's important to drive and to follow these international activities there. We really have the goal to be a center point in these networks. We have the extension and the developments of the networks in Eindhoven and Delft. We have the goal to build that national networks in a couple of years of now, but also we are in discussion with neighboring countries at the moment to build cross-border networks and connect it also to satellite infrastructure, where we also have an important role in the development of that within Europe at the moment. And that's important for us within the Netherlands and the development overall if it comes to the quantum network technology. If it comes to quantum technology, we have just started. If you look into the equipment, if you look into the quantum computers, you can't translate this nowadays or place this in a regular data center. For instance, for a quantum computer, you need cooling. Minus 300 degrees is necessary to get the qubits stable there. And therefore, you need dedicated equipment. And that is currently not available in a data center of Equinix, DataPlace, or others. And also, if you look into the bets to build that distribution network for quantum technology, it's lasers, it's mirrors, it's etc. There are some boxes already available, but the early states there. And upcoming a year, 2 years, it will be translated in 19-inch boxes, etc., that we can deploy in actual data center setups, etc. But that's all to come the upcoming period. I hope you get an idea what's happening at the moment in the Netherlands and in Europe if it comes to quantum networks and quantum technology. So if you have any questions, don't hesitate.
Yeah, so there are no questions currently. There was quite a vivid discussion about whether protons or electrons were used, but well, I can't even follow the whole conversation. So, but there were no further questions. There isn't one right now of Michael. Do you have any idea if there are more networks out there that already exist?
Now there are different test networks globally. So as I said, in China, there is a big network as they're telling at the moment. There are different networks around Chicago where they test also different quantum key distribution solutions. There is an idea of a deployment of a network in Bavaria, in the southern part of Germany at the moment. And there is a lot of money came available from the European Commission and local governments in Europe to deploy other networks in different member states in Europe. So there's a lot of development there and upcoming networks that are under construction or will be deployed the upcoming year.
And the network you mentioned, running from Delft, also beneath our building, is that a new network or did it already exist? Where is? Okay, Jesse is gone. We lost him. There he is again.
I was interrupted on a short one. No, so the network concept is new. The hardware on top of the network is also completely new. But the dark fiber infrastructure that's probably what we can reuse and that we don't have to deploy again. But also in the Netherlands, we try to learn what's happening there, how is interference working, how are influences from other networks close by, and attenuation, how is that affecting the qubits at the moment?
I got one question, Jess, which I never understand. So I'm very not knowledgeable of the subject, but can we transfer faster than light? Can we transfer data faster than light with quantum networks?
No, at the moment, not that I know.
Is that going to happen? Because that would be awkward, right?
It would be really awkward. I don't know.
John says nothing can be faster than light.
Yeah, that's what I learned in school as well. So. Hence the question.
Let's stick to that.
Okay. Currently, I think if we are really happy if we can have a stable connection where we can have the stable qubit from one to the other side and do this on a long distance. I think if we make that step already, that we can build quantum networks over 100 kilometers or longer, then we have real steps that and deployments that are also cost efficient on the short notice.
Okay, and we also got an interesting question of Leon. Which physical implementations of qubits are most promising, according to you?
Yeah, at the moment, there is some discussion there in the media, as I'm aware of, but at the moment, the spin qubits are quite promising, and on many institutes in the Netherlands, but also internationally, we are looking at it. There are some developments also on other types of qubits. Some are successful, some are really, really early stage, and we need to do a lot of development there.
All right, thank you. Well, there are no questions right now. Well, then I would like to thank you very much, Jesse. And yeah, for me, it was really nice to get a quick introduction in the matter. I still can't get my head around it that something can be either both a 1 and a 0 at the same time. But I do think it's really interesting also beneath our building at the office. Actually, qubits are running by, so that's just nice to know, right? If you have anyone over, you can just brag about it. So, yeah. So that's also really cool to know. So thank you very much for this introduction into quantum internet, and I've learned a lot, and I hope the others have done so as well. I see a lot of things coming by in the chat, so those things are also to you. And yeah, so for everyone that's still here, you can go to the social, the Meebo. You can see the link in the chat, and if you go there, we'll have a nice social together as well. So again, thank you, Jesse, and
thanks.
Thank you all.
Thanks.
See you all at
See you in the social.